Hey everyone, in this video, you're going to learn how to get started with ADK. That's Agent Development Kit. This is a framework from Google to make it really easy for you to build agents that can work together. First, let's talk about what is an agent. An agent is an LLM with tools running in a loop to complete a task. ADK is going to give you a framework, so a lot of that boilerplate code that you can avoid writing that will help you equip an LLM with tools and then help you handle the control of it running in a loop and deciding when it needs to stop working on a task, etc. You also get some really nice interfaces for testing out your agents during the development process. So first, we're going to walk through how to get to Hello World with ADK, how to build your first agent, how to equip that agent with some tools, and then we're going to look at building a very simple multi-agent system. Before we get started though, there's a couple pieces of setup you're going to need to do. You're going to want to go to AI Studio to generate an API key to interact with the Gemini API. You're also going to want to pip install Google ADK. And I recommend doing all of this within a virtual environment. But once you have an API key and once you have the ADK Python package installed, then we can get started. To create your first agent, once you have ADK installed, you're just going to do ADK create first underscore agent. Cool. All right, once you've created your first agent, you can choose what model you want to use with it. And so we will do here Gemini 3 Flash Preview. And you can see that the code to create your first agent is pretty minimal. We're really just importing the Google ADK agents library, and then we define an agent just passing in a few parameters. So it's the model that we're going to use. That's the name for the agent. We'll just call this one Getting Started. And then a description of that agent, and then instructions. This is also known as the system message or the system prompt. For this case, let's just say you are an assistant who is helpful but brief. All right. And that's it. That's all you need to write in order to create your first agent. Now, one thing I really like about ADK is that it makes it very simple to test your agents. So I'm going to switch over to the terminal here, and I'm going to type ADK run first agent. All right, then to test our agent, we're just going to run ADK run first agent. And we have this dialog here, and we can just say, hello, how are you today? And we'll get a reply back from our agent. So this is a way that we can test our agents built in ADK right here locally. ADK comes with another really nice feature, which is a web interface to test these as well. So I can also type ADK web, and you see that it will spin up a web server here. And then there is a URL, a 127.001.8000. And if I go and open that up in a browser, you can see that I have access here to my first agent. I can also type, hello, how are you today here? And I can get responses from my agent. And then I also can see the stack trace. And so this web interface is really, really helpful when you're building agents for debugging purposes. All right, so that's how we get started with ADK and how we build our first agent. But right now, all we're really doing is having a conversation with an LLM. And that LLM is a little bit limited in what it knows and what it can do. Of course, it's been trained on an enormous amount of data. It's very powerful, but that data has a cutoff date. And so if you were to ask the model, for instance, what time is it, or what is today's date? If it gave you an answer, it probably would not be correct. The correct answer is it doesn't know, right? Because LLMs do not know up to the date information. But we can equip LLMs with tools so that they can retrieve up to the date information, or so that they can perform tasks. So let's look at equipping our agent with its first tool. I'm going to create a new agent here called Timekeeper. Very similar structure. The only difference from our initial agent is that we are going to add a function at the top of this file called getCurrentTime. That getCurrentTime Python function does a very simple thing. It returns the current date time. Then the second change that we will make to our file is that we are going to add a line called tools. And that tools has a list. And the list here only includes a single function, and that is getCurrentTime. So we basically have defined a tool here in getCurrentTime, and then we have equipped the agent with this tool. And note, because this is a list, we could equip it with multiple tools, but here we're just giving it a single tool. So now if I go back to my command line and I run ADK again, and I test out this agent will have access to the current time and date. It's called timekeeper. And great. And so now when we run what time is it, it says it's currently 1:30 p.m. on April 2nd, and I can confirm that is the date and time that we are recording this currently. So what we've done here is we've given the agent access to a tool so that it can get information that the LLM would not have had available to it before. This is a really, really powerful concept because this allows us to extend the abilities of the large language model almost infinitely. Let's look at adding another tool to it, and this one will be Google Search. So this is another agent. This one looks very similar to the timekeeper agent that we just created. The difference here is that we are not defining the tool here in the code. Instead, we are just importing the Google Search tool. This is a tool that is baked into ADK, so you get it for free with this framework. And then we add down here to the tools, Google Search tool, and we are telling it to bypass multiple tools limit. By default, there is a restriction that only allows it to do a single tool call, but Google Search often needs to do multiple tool calls in order to give you comprehensive results. So we're gonna set bypass multiple tools limit to true and give this agent access to the Google Search tool. And now if we come over here to ADK and we do ADK run search agent, we're going to say here, when does the next episode of... All right, so now when I ask my agent, when does the next episode of Top Chef air and what's happened so far this season, the first thing you're going to notice is that we get a much longer delay between my query and the response. But then we do get a longer response back. Let's also take a look at what it's doing in the web console. So I'm going to go into the web interface here and I'm going to ask my search agent, when does the next episode of Top Chef air and what has happened so far in this season? Now you can see that it takes a little while for me to get a response back, but that's because it is going out and it's searching Google to collect this information. And if we want to click on our search agent here, you can see on the left-hand side that it's going to show all of the sources that the Google search tool searched for in order to gather this information and to compile the results. Over in our summary, we have our recap, and our recap even gave us the sources back. There might be one problem though. Some of these sources are going to 404. So this is not perfect. And we did actually search and search real sources to compile this information, but LLMs still sometimes hallucinate URLs. And so what I want to do is build a multi-agent system that will confirm the data that is being reported back by this search agent, right? So we're going to verify the URLs that come back. So let's move on to the third part, and that's building multi-agent systems. All right, to build our multi-agent system, we're first going to create another agent, and this one is going to be called URL verifier. Our URL verifier agent is a little bit more complex than what we've seen so far, but the main thing to keep in mind here is that we are equipping it with a tool called fetch URL. And we're going to pass a URL to this fetch URL, and it's going to return the text that is located on that web page. Then we're going to set up an agent that is going to take in the information from that URL. It is equipped with that fetch URL tool, and it is going to return verified, not verified, or inconclusive. So we basically have built here what some might call LLM as a judge. So we're passing in information from one large language model request to another, and we're giving that other one the tools to verify if that information was accurate or not. We're going to set up a second agent. This one is going to be called our researcher agent. So our researcher agent now has two tools, but those tools are agents. All right, so this is where things can start to get really powerful when you are equipping agents not just with tools that are deterministic functions that run, but when you are equipping agents with other agents as tools. So in this case, our researcher agent is going to serve as our orchestrator, and we are equipping it with the search agent and the verify agent. as tools that it can use in its process to verify this information. We change up the instructions a little bit. We tell it that it is a research assistant, that it needs to use the search agent tool to find information, and then it's going to use the verifier in order to confirm that that information is accurate. And so now if we come over to our web interface and we ask, when does the next episode of Top Chef air? We can see that it is making multiple tool calls in order to get this information for us. So it is using first the search agent, and then it uses the URL verifier in order to pull up the information on that URL and confirm if the information that the initial search agent had retrieved was actually correct, and to confirm that that URL actually does exist. So in this way, by combining multiple tools together and by equipping an orchestrator agent with multiple other agents that only have a single purpose, we're able to overcome some of the limitations of large language models. In this way, you're able to give each large language model or each agent a very specific task, and you can have better management of its performance, of its memory, of its cost. We could also have each agent being powered by a different large language model. So for instance, for simpler tasks, we could use a cheaper and faster model. For more complex tasks that required more reasoning, we could use more expensive but more advanced models. So these multi-agent systems give you much more control over the types of tasks that you can accomplish, and with what certainty you can accomplish them, and then with what cost it requires in order to accomplish them, than you can get by just building one agent that has a whole bunch of different tools. If you'd like to get started on this, just visit adk.dev and walk through the Get Started.